So the way I wanted to start off this conversation was actually with a quick thank you to you, Matt, because you don't probably know this. I know Alice indirectly through you because I think 3 years ago I was looking for my first job and I was almost going to work for you under Ynomia because you were the first person I cold emailed. And I remember agonizing over this cold email and then you just responded and you're like, oh, do you want a job? And I was like, yes. And it really opened my eyes that I could email anyone and they could respond. A couple of months later, emailed Alice and was like, I know Matt from Ynomia, who's your portfolio company. And then we got in chatting. And that's how this podcast now has come about. Where I want to start this conversation is a little bit of context setting around Ynomia and how Ynomia came to be. So I think it's really interesting because Ynomia came out of a commercialization of research from Australia's research agency, CSIRO. And the research which worked in a lab setting was BLEAT, which is Bluetooth Low Energy Asset Tracking, and it could be used for supply chain asset tracking. And what you recognized was that this potentially could have a value in the construction ecosystem, and you managed to scale it outside of a lab setting to a construction projects, and were able to create a connected job site. So you could track people on your job site, materials, equipment, which, as you can imagine from a progress tracking or a scheduling perspective, is incredibly useful. But there's some hard-won lessons there where I see a lot of research coming out from university and it connects to a problem statement and I go, is this actually feasible? Can this work outside of a lab setting or can this actually be scaled to a construction project? So I wanted to know, is there any hard-won lessons that you know when you see research these days of understanding if it can be applied to our industry and if it can be scaled effectively? Is there a way of kind of validating that?
Sure. Well, I think the first point I would make to touch on what you opened up with is the greatest lesson of my experience in this realm, because, you know, as you both know, my background before was originally in corporate finance, but subsequent to that was in a logistics technology business. And coming out of that, I had zero network. I didn't know anything about construction. I didn't know anyone in construction. And the thing that's been really amazing to me, and I would say, if you fast forward 6 years to now, or nearly 7 years from when I first started making those cold outreaches like you were a few years ago, the willingness of people in the construction industry at large, and maybe if you focus into different segments of that, to be willing to have conversations with someone they didn't know, who they didn't even have, you know, a first level connection with, or because I was like not from that world or from this world. Austin at Brick and Mortar was the first person, you know, who I had reached out to, not because in my wildest dreams I thought that we would secure funding from Brick and Mortar, but I had done enough research to understand, you know, who Darren was, and that, you know, if you're starting from ground zero, you have to shoot for the stars, right? You have to say, well, who would be the best people in your dream scenario of who you could be connected to in this industry, and you start reaching out to them. And, you know, fortunately for me, that kind of led me down a path where, I mean, Brick and Mortar opened up an inordinate amount of opportunity and relationships and just, you know, like happy times of being able to spend time with great people. But I think that's the first lesson, that if you're coming into construction tech, and whether you're coming from a construction background or whether you're coming from a totally different background, don't be afraid to reach out to absolutely anybody, because I think the willingness of people to engage, and if you're respectful, I think, you know, if you show that you know that you don't know what you don't know, and that you want to learn and you want to ask good questions and you care about, you know, making an impact in that industry, I think that's true. And that's true whether it's construction tech or to your actual question around research IP. I mean, I was in a similar boat. Like, I'd never dealt with any publicly funded research organizations. I didn't really understand the process of commercialization. Like, I understood, you know, commercialization in a commercial context, as in, you know, we have a product, we want to go to market, we have to find product market fit. Like, I understood those concepts, but how do you actually take something that is not a product, it is some form of intellectual property, tangible in some aspects, intangible in other aspects, hard to kind of understand and wrap your hands around. It's not a physical product that you can see and feel and touch. And because you're dealing with a government agency, there's a whole lot of other complexities, because to get that intellectual property, in this case BLEAT, to the point that it was, the money came from the government, which actually comes from the taxpayers. So the way that they have to engage is clearly different to the way that a commercial organisation can, because they, you know, are funded by shareholders or investors or whoever it might be. And so I think when you're approaching working with publicly funded research agencies, CSIRO being one of the largest, you have to kind of think about it from a different mindset, partly because of the organizational dynamics that exist within, say, CSIRO because of where their funding comes from. And the other part of it is really that the individuals you're dealing with. So, most people have dealt with academics, I would say, is probably the closest thing to researchers. And they are incredibly brilliant in certain aspects, hence they can create things that don't exist. But they also, because how they define success is often different than how we would define success, because success for them might be that they get published in a journal. It might be that they create something that is new and innovative, but whether that actually solves a problem in the real world, whether it ends up being commercialized and monetized, those aren't the things that they have to be thinking about, because that's just not their general time horizon or their general field of focus. And because they get funding on relatively short windows of cycles, they can't really plan too far ahead. It's kind of like, how do I make the next iteration of this thing to show that it's got some sort of form of potential? But most of that's being done without market testing, the most important thing to understand if it actually has a pathway to market and to some sort of a commercial outcome. So I think understanding who you're dealing with, both the people, the personalities, and the organizational dynamics is important. And then I think the other thing too is to just be really realistic about what you've got to start with. And I think like a lot of people, and why you'll see anecdotally that commercialization of research IP is very hard, and the success rates are lower than startups, which is probably not a great statistic, because it's a low bar. But a lot of the reason why is because of some of the factors I just mentioned, but also you as someone who's engaging with that organization, they talk about something in CSIRO called the halo effect, which is kind of more broadly applicable, but it's that you have this perception that they know all, and they have this infinite understanding and knowledge, and therefore what they've created must be at a certain level of capability, sophistication, refinement, whatever. And because it's publicly funded, the amount of due diligence that you can do on what you're trying to commercialize is extremely limited. So if you were to acquire a construction tech business, the level of due diligence you would be allowed to do, you'd look at the code base, you look at the architecture, you'd be able to do a whole bunch of different things. And even because most software products are publicly facing, like there's a whole lot of things that you could do in terms of stretch testing it. You could talk to customers. There's a whole way you could do due diligence on that sort of, in that sort of world. But in this world, that's not possible. It's very much, we'll show you enough for you to get a general understanding about the concept of how it works. Because aspects of that technology hadn't been patented yet, they're not allowed to talk about them publicly, because it would potentially invalidate the patent. And so you're kind of working in this black box of information and having to make somewhat educated guesses about what level of sophistication, and you're probably both familiar with the TRL scale, which is the technology readiness level of something that is coming out of a research lab. And it's a self-assessment methodology, and it's pretty abstract. It's kind of like, when you do a survey of, how was your experience at wherever, it's a 10-point scale. There are some boxes you can tick that can get you further up that scale. And because it's self-assessed by the research organization, the way that they would look at that, and Bleat was assessed at about a 4 or 5 on that 9-point scale, that means that it works in a lab. And what does that mean? Well, I now understand that means that it's not very advanced at all. But to me, working in a lab as an uninitiated person, it had a different context around it, because I thought, okay, it works, it just needs to be scaled. But we grossly underestimated the time, the money, the effort that it would take. And I think ultimately the biggest challenge that we faced, aside from timing and the pandemic and not being able to get access to sites, which was difficult when you're trying to test a network technology that has a hardware component which has come out of a research lab and has multiple breakpoints. If you can't physically interact with it, it's hard to know. We had a project running with a good friend of Alice's in Austin, and it was, like Groundhog Day. We would always chat about, when that network was up and working, wow, that could have been an amazing, impactful thing in the industry, but the network just couldn't stay up and connected, and because you couldn't physically be there to diagnose where the failure points were. I mean, we were working with sample, like prototype hardware. So, if the hardware unit itself is failing, sometimes it was as simple as turn it off and turn it back on again, like the oldest trick in the book. But if you can't physically go on site and do that, that's really problematic, because when you're not seeing data coming out of the network, you don't understand why it is. So I think the realization that whatever assumptions you make, and you want to look at it as glass half full because you're an entrepreneur and you have to believe, that anything's possible. If you're working with research IP, I think you have to take it more sadly from a glass half empty, or the glass has got nothing in it, and whatever you can extract out of that glass is good, and it's a bonus. But if I look back now to when we did the first funding round in 2019, the idea that when you've got IP that needs to be made to work in a commercial setting, a very difficult commercial setting being construction, and then you have to deliver on use cases that actually solve real problems, those two things in and of themselves both would have required probably more funding than what we had access to. Mm-hmm. Trying to do them both together was ultimately, nothing's impossible, but it was very near on impossible, because you are trying to prove out the core capability of Bleep, but you're also trying to solve the problems in the field. I think being more pragmatic about that and saying and Curtis and I had various discussions about this, about whether it should actually be a network technology as opposed to a workflow use case, actual problem, or whether it should be sort of a layer down in the technology stack that other products are relying on top of it. And I think if I had my time again and we could do it again, yes, I would have wanted to understand more about where it was at with CSRO. We probably would have negotiated different terms with them, knowing how much money really needed to be spent and how much more support we would need from them beyond what we could get from investors. But I think if we had have just focused on, that's all this is, it's a network technology, it's an infrastructure layer to provide connectivity, but not going down the path of, on top of that, building out, because then there's a whole lot of other complexities. When you talk about, tracking in the construction context, tracking of people has a whole lot of practical challenges. Tracking of equipment has a whole lot of practical challenges. Tracking of, materials, especially if they're off-site, let alone, on-site, off-site, whatever. But each of those individually has a whole lot of problems to solve. And I think if you had something that came out of the box and worked in terms of the underlying tracking capability, and you went after one or multiple of those use cases, that in and of itself would be a challenge to achieve scale. But when you're trying to do all of those things, because also you're trying to read the market, if you go back 6 years ago, there was a lot of excitement about IoT, but if you thought about where maybe our thesis of where it would get to today, it hasn't advanced anything like what you would have expected it to. And a lot of that is because of the underlying challenge that it's hard to connect a dynamic transient construction site. And those use cases, all the same issues still exist about, the tracking of workers, or even if it's in the context of health and safety and, protecting their well-being, those things haven't really changed. And the pandemic changed lots of things for the better, but some of those practical constraints around asset tracking in construction, I think, haven't really gone away.
Yeah, and just to, if I understand this correctly, you're saying there's almost two parts when you're taking spinning research out. There's one part which is trying to improve the TRL of the underlying research IP. And the second part is actually finding the use cases and making it work on site. And if you're doing both at the same time, it's very difficult. But if you can increase your TRL and then find the use cases, so you almost get your first funding round just to further get support from CSIRO, make the technology at a level where it potentially could work, and then start to look at use cases. Would that be a better approach or a more interesting approach? Because it feels like there's something in between there.
Yeah, I think, the unfortunate reality is that you go back then and you probably don't understand that that's what it will take. And like I said, the glass is overflowing mentality of an entrepreneur is your biggest detriment, because you think you can do all of that. Absolutely, you can do all of that. Why could you not do all of that? But then when you go to step one, okay, let's take this technology out of a lab and let's put it into a construction site. And we were incredibly fortunate. The first construction site we worked on was in Melbourne. It was an 80-story tower. We had pretty much unrestricted access. We could kind of go anywhere. We could do anything. And I think we talked about how we overcame some of those practical challenges because we tracked more inanimate objects, things that, gave us a chance to sense test, is the network actually working? Is this thing where we think it should be, but without having to deal with some of the other constraints that you would have to deal with. But when you go to that, you would have to be going and remembering that none of this is possible unless you can get a deal done with CSIRO to even get the IP out of the lab and get it moving forward and get control of it, and get control of it on terms that, we spoke to a lot of investors, potential investors, who, their expectation in terms of the terms you could get with CSIRO, in terms of the future royalties you would pay, you can't give too much away because otherwise you're impinging upon your ability to then raise capital, because to an investor, they will say, well, you've given too much of the value to the research organization, you've capped your upside because now you're going to pay, a trailing royalty of XYZ, whatever that might be. So you have to probably go harder on the commercial negotiations. But what comes with that, and if you're doing that at a time where it's a chicken and egg, you don't have funding yet, so you can't commit to a large upfront royalty. And also because you don't really know what you're getting, it would be more risky to do that. And so you're sort of stuck in this place of you're trying to negotiate those terms. And the pool of, especially nearly 7 years ago, the pool of investors who would have had the appetite to fund what would effectively, if we had just done the first part and said, here is some research IP, we want to commercialize it. We don't really understand how or why or what it could be used for. We just want to commercialize it. That's not even really in brick and mortar's wheelhouse. I mean, brick and mortar likes to be early with companies, and that's why Formwork exists, obviously. But there are very few. That's more like in the vein of, Main Sequence Ventures in Australia is there. It exists, as a fund only to back publicly funded research. Now, the problem you've got is that if you're, like anything, if your pool's really, really deep, your options are more, are more voluminous. But if your options are limited, if there's a very small number of investors who would back that as a concept, then getting their attention for something that's at a low TRL is even more difficult, because Main Sequence, if you actually look at their investing process, they tend to invest in things that have received tens of millions of dollars of funding within the publicly funded research organization, because it's more bankable. They know it's almost like a leading indicator, right? This was created by a researcher or a research team, and then someone was prepared to put budget to it, and then someone was prepared to put more budget and more budget and more budget, and it must have progressed not just because of the volume of money that got spent on it, but because it was going through certain internal gates and tests and hurdles. We were working with something that internally within CSIRO had less than $500,000 spent on it. It was very, very early. They'd run an expression of interest campaign, which is basically the way they try to get these things out into the world, and they didn't have any interest in it because it was so early and because so little money had been spent. So the normal lens that you would assess something like that across would say, let's let CSIRO keep, tinkering with this for some period of time, and then maybe if they get further with it, then we might consider it. And I kind of stumbled across it once a year, CSIRO has an event where technology like that or IP like that gets showcased by the researcher in a public forum, and you can talk to the researcher. And there were certain things about his approach in terms of his desire to use Bluetooth, which it then and now remains from a short range communication protocol, still the gold standard, and probably will be for the foreseeable future. Combining that with a long range protocol, which at that point was LoRaWAN, like that was pretty unique and novel, and that to me was the way you could overcome the tyranny of distance, that you need localization in a construction site, but you somehow need to get the data off the construction site and make it visible to others who aren't physically in that local area. And so that was probably what I saw as being unique and novel, but I probably didn't understand that, yes, it's unique and novel, but it's a long bridge, it's a long road from there to getting something that would work in a reliable fashion.
How did you build conviction in construction? Like, how did you decide construction?
Yeah, that's a good question. In some ways, it was following a similar process. So I was fortunate in my career that the first part of it was spent in mining and natural resources, which is a massive industry. And as much as I worked on the M&A side, I did get to see at an operational level, how technology had started to come into, into mining and oil and gas and be used in a bunch of different ways, and kind of seen that and was able to take what I learned within BHP and that industry into logistics, because logistics was kind of at a similar inflection point where it was starting to digitize. There was still a lot of analog process, a lot of paper and pen, a lot of things that were quite antiquated, and tracking of product. I mean, now you can order something on Amazon, it gets there the same day. You can see it. You can book an Uber and you can see the driver. You can see when he comes towards you. Yeah, back then you couldn't do any of that. Like, none of that stuff existed, and so I probably had been fortunate to have two lived experiences of coming to an industry at a time when it was starting to digitize, and seeing how impactful that was, and being able to participate in some way in doing that. And so when I was coming out of logistics, and because of the nature of the way that we exited that business with the sale to Singapore Post, I knew that I had basically a 5-year non-compete, which is a long non-compete to have in an industry that you've just spent 10 years, like I said, building a network, building relationships, building a reputation, and building a business. And so I knew that what I did next wasn't going to be in that field, because it couldn't be. And so when I kind of started thinking about, well, what are the other, mega industries that are probably embarking upon a process of digitization? McKinsey was putting out a lot of material back at that point in time, those sort of famous reports that lots of people reference, and probably still get referenced in pitch decks and presentations now. But it was pretty compelling, right? Like, if you're sort of me, who's thinking, well, how do you take what I knew and what I learned and apply it to an industry? It had scale. It had all the things that an investor would look for. Does it have a big TAM? Does it have a desire? Seemed to be a perceived desire that people were talking about the fact that there has to be better ways of doing things. There's a lot of macro forces around the need for more housing and more infrastructure, and sort of emerging trends around some of those things. So yeah, that's kind of why construction. And then it was kind of like, as a subset of that, okay, well, that's construction, and then the stars kind of align where the construction seems to be the place to start exploring this thesis of well, then what are the problems in construction? And again, those McKinsey reports were nice because they'd sort of put them in spider diagrams and you could see the pots of gold, and potentially where are the areas you could impact. And again, like I said, if you go back then, I think the people at McKinsey and KP or whoever else was there at the time would probably be disappointed in the rate of which some of those technologies that they perceived were on the cusp of really starting to scale. They haven't really. I mean, we're still, I would say, in the phase of analog stuff being digitized, things being taken out of spreadsheets and putting into workflow based tools. And I think I probably overshot the mark in terms of thinking that and even, I mean, Alice, you're involved in robotics and other things like that. I mean, the rate of adoption of hardware based software products for the construction industry has gone a lot slower than what I really ever would have expected, and it doesn't seem as if there's a strong current of tailwind behind it now. So yeah, I think it's for me, it was probably understanding construction as a market opportunity for technology, seeing this IP, saying, well, is there, if you had a Venn diagram, like, what is the section in the middle where asset tracking fits within a construction technology context? And I, at the time, felt like that was a big enough segment that it was worth going after, and still believe that, but believe that that it's probably a next phase or a next wave, or maybe even the subsequent wave when that starts to become more predominant. I mean, I don't know what the market data would say about money that's spent on construction technology by product category, but to me, it would still be an 80-20. There'd still be document management and design tools and things like that would still be getting the lion's share of the share of wallet in terms of dollars of spend. And I think those more emergent technologies are still being used because it's such a big industry, right? Someone's always going to be prepared to trial it, test. I think that's, again, the blessing and the curse of going after such a big opportunity, is that there are lots of people who are willing to test. And we got to work with some amazing people in Australia, in the US, in the UK. Almost consistently, I was amazed by how willing people, and having brick and mortar provide introductions obviously helps, but beyond the introduction, you have to be having conversations that people, smart people like Charlie Dunn and others, like, care enough about to say, this is the thing I could spend some time exploring. Encore, people like that as well. So I think yeah, being able to think about that in the context of the industry you're going after, and like I said, the research IP that you're trying to bring together, and I guess being confident that part in the middle is big enough, but also, like I said, being very pragmatic about what you've got to work with from the beginning and the amount of funding that it would actually take to get that to work. And then to your point, Bhragan, I think the how you sequence that work and how you pitch that, because it has to be, investors accept that where you start is not always where you finish, and that things ebb and flow over time, and you're always recalibrating relative to new feedback or new market information. But I think you have to make sure that you've got an alignment, and in some ways we didn't have a solid enough base in Bleed to be going after use cases at large, let alone those that are in the construction industry that relied upon the lean startup. He talks about leap of faith assumptions, like the things that have to prove true for you to ultimately be successful. I mean, some of those leap of faith assumptions, about how adoption would progress in construction didn't really happen in the way that maybe I or others would have thought.
Yeah. I mean, back on the point on, hardware and robotics, I think we have seen kind of a bit, easier in terms of calculation of ROI there, right? Like, I think if you're doing robotics specifically, you can calculate how many man hours does it take, how long, and it's a pretty easy calculation when you do the replacement using some type of new machinery. And on the hardware side, like, I don't think anyone has solved job site connectivity still. And I don't think anyone has solved material tracking still. And I don't think that it's the industry not interested, because we still hear about this pain point all the time.
Yeah.
I think it's more that the technology just hasn't matured enough yet, frankly. And across almost all the hardware if you lump robotics into hardware, I think across all of those different solutions, I think some of the main challenges have always been on the implementation side, right? Because software in some sense is a lot easier to implement. If it's not an ERP system, it's a lot easier to implement, because it's like, okay, go on this website and click this button, right?
Yeah.
Whereas when it comes to anything that's physical, the implementation is a lot harder. And I think it's just with construction, everyone is so busy that it's like, if it doesn't work the first time, chances are you may not get another chance to do that again. And I think that kind of adds to some of the challenges. But at the same time, I don't know what the answer is with, how mature does the technology need to get to kind of, and Curtis always says, first contact with the enemy, right? Because there's a little bit of figuring that out there. And then, yeah, and to your point on, research, right? We do need all of this research, because there's no the construction industry doesn't have an R&D budget to go, find new technologies, right? They're not going to go invent the next Wi-Fi. They're not going to go invent the next whatever. So we are kind of also dependent on all these adjacent industries or research labs, right? So I don't know. I think for us, we still need all of these technologies to exist. I think we just need, more funding. So I'm here pitching. We need more investors to invest in, the hard tech for construction.
Yeah, and you're right. I mean, the people in construction are busy and overworked. And so, like you said, if someone says, we used to use app A and now we're using app B, and it pretty much works the same, and generally speaking, there's been a whole lot of pre-work that's gone on to building out forms and checklists and things that, they kind of look and feel pretty much the same. People can make those transitions because it's just kind of doing what they did in a different way. In some cases, it's taking something of analog and making it digital. That's easy enough. I think with hardware, and if you looked at the thin end of the wedge, like the hardware-based construction tech that's doing better, I think your example there, Alice, is a good one. Like, if you thought about, I'm not sure the company that does the set out with robots. So I mean, that is almost more like it's hardware-based construction tech as a service, because the robot goes in, it does a thing, and then it kind of moves to the next place, and it's kind of one and done. I think anything that requires more of a setup, an infrastructure, a networking technology is probably why those things haven't existed. Why we were trying to build something that was entirely battery operated, because
Hmm.
it was obvious from very early on that that challenge of if there was any level of maintenance involved in in the network, it would be very difficult. And if you relied upon local power, still today on construction sites, I know Curtis has done some great stuff to try and improve those areas of power to construction sites, but it's still a problem. You still go on and there's like, limited, leads going everywhere and there's limited amounts of points. And if something's plugged in, someone wants to unplug it and there's, there's so many things that a technology that has to exist for the life of, a project, which could be, months or years, that has to come with some level of support and maintenance and performance. Ultimately, if it's performing, great, because then it's delivering value. But I think, like we had visions of connected tools. If you took connected tools as a use case and said, the number of people that we spoke to in early discovery about, can't find the right tools, it slows us down. Like you said, Alice, it's harder to quantify because people don't think about, well, how many hours a week do you spend looking for tools, and how often does it you get delayed, and then the next person gets delayed because you didn't do what you were supposed to do. It all just kind of gets lost in, the program gets status. Oh, Alice didn't get all that stuff done. Okay, fine, she'll do it tomorrow. She'll do it next week, and we just kind of move on. There's not a lot of root cause analysis of why did she not get it done, because of materials weren't available, or she couldn't find them, or tools weren't available. So a lot more connected tools exist. That's great, but they sit across multiple vendors. All those vendors have their own app, their own, kind of way of having connectivity to their suite of tools. But to me, if you had a network that was tool agnostic or brand agnostic, and it didn't care if it was a Milwaukee drill, if it was a Hilti, whatever, and you could see all of those things, like, to me, that is today was then and still today would be a really valuable thing. But the fundamental question of people need to care enough about that problem of, can I find my tools at the right time? And I think, materials, what we ended up finding and why the sale of Ynomia has been so successful is because tracking of materials, I think, is a compelling use case, and it was always a compelling use case. But doing it in a DFMA context was the sort of silver bullet that I didn't figure out until too late. But once we figured it out, and Ynomia was sold 2 years ago, and has now focused exclusively on a narrower subset of projects, which is, when there's larger scale, when there's multiple factories involved, when the components have to go through a design to manufacture to supply, so it's not just commoditized product that can be taken off the shelf. That is the sweet spot of where that really makes a lot of sense, and the ability to visualize that. Our original conceptualization of a digital twin of the building, the users today in the UK who really gain a lot of value from Ynomia would say that their ability to, in a web-based environment, interact with the building with no BIM expertise whatsoever, and be able to see the life cycle history of those components, to see where they are, to see where there's potentially delays in the process. Because in DFMA, just in time is much more of a factor. So getting the right things to the site at the right time, the delay is real. Whereas with most other, sort of made to stock type of materials, you can probably have buffer stock sitting on site somewhere close by off site where you can kind of resolve those issues. There's a lot of working capital tied up in that, but that's probably a different issue, that the people who are holding the extra working capital aren't really concerned about that. They're concerned about not having delays, which is understandable. But when the cost of a component is thousands of dollars or pounds, tens of thousands of dollars of pounds, you can't just sit on a whole lot of inventory, because the cash that's tied up in that becomes more significant. So I think, again, the lessons learned, if you could go back at the start and say, well, that is the sweet spot, just focus on these kind of projects, components, whatever those things might be. And also the interconnectivity between other systems. I think the physical tracking of objects or components in that context, in a DFMA sense, is important. But the richness of information, and partly driven by regulation in the UK, where they have something called the digital golden thread, which is a legislated requirement that you have to be able to show for a component of a building, especially something in a DFMA context where it's something to do with the structure or the M&E, or something that's a key component of that building and how it exists and how it will exist in the future. The ability to, every component that gets tracked in Ynomia now would have had data fed into it in an automated fashion through probably half a dozen different systems. When drawings got issued, when they got approved, who approved them, who did the physical inspection of the component, when it left the factory, when it arrived to the site, when it was installed, what were the tolerances, how far out of tolerance was it? A lot of that data is not originated from Ynomia, but being able to click on a component of a building in a web browser and see this is the historical life cycle of everything that ever happened with that data feeding in from Viewpoint, Aconex, Procore, like a whole bunch of different systems. I think that was something that I probably didn't understand enough, that and the proliferation of different tools in construction tech means that you have to start from the place of, well, which is the part of that information journey that we want to be involved in the capture and creation of, and then what else enriches that or makes it valuable to a user that is readily available if you're able to go and kind of connect to it and create the right structures and data structures and consistency in terms of that this, when drawing XYZ happens, what does that actually mean? Well, it means these 50 components have now been approved and they could then be manufactured, and if the right people know about that, rather than someone at a factory is waiting to someone to tell them that a whole bunch of drawings got approved and they don't really know because they haven't got visibility to Viewpoint, the system that happened in, sort of unlocking all of that from a transparency perspective, I still think there's inordinate opportunity in construction to be able to bring that kind of to bear.
Thank you so much, Matt. And thank you for your passion for the industry. I'm glad the industry has won you over.